I am Albert Einstein. This is a recreation built on artificial intelligence based on my documented work, lectures, and verified writings. Imagine you are sitting in a cafe in Bern. It is 1902. Across the room, a man reaches for a second piece of cake. You watch his hand move before his intention has even formed in his conscious mind. That gap between the decision and the action, that is where physics lives. That is where the real question about sugar begins. Not in the cake, not in the taste, but in that infinitesimal delay where the brain has already decided what the body will do. I spent my life studying that gap. In 1905, I published 4 papers that changed how humanity understands space, time, energy, and matter. One of those papers introduced what would become the most famous equation in history. But I never imagined that the same principle behind E=mc² would help explain why you cannot stop eating sugar once you start. Energy cannot be created or destroyed, but desire, the desire for sugar, can be amplified beyond all reasonable proportion. And that is precisely what happens inside your skull within 6 minutes of your first bite. Let me show you what I mean. Subscribe. Leave a comment. Tell me, when was the last time you ate something sweet and felt genuinely in control of that choice? I was sitting in the patent office in Bern when I first began to understand that the universe does not always wait for our intentions. Light moves at a constant speed regardless of the observer. Time bends when you move fast enough. And our sense of choice, our feeling that we freely decide, bends when certain molecules enter the brain. Sugar is one of those molecules, and it does not ask for permission. Here is what happens. You eat something sweet. It could be a cookie, a can of soda, a bowl of cereal with brown sugar on top. The sugar travels through your stomach and enters your small intestine, where it is broken down into glucose. Within 2 minutes, glucose floods into your bloodstream. Your blood sugar rises. Your pancreas responds by releasing insulin, the hormone that acts like a key, unlocking your cells so they can absorb this fuel. But that is only the mechanical part. The real transformation happens in the brain, and it happens faster than most people realize. Within 6 minutes of consuming sugar, the brain's reward system activates with surprising intensity. Dopamine, a neurotransmitter that functions as the brain's natural reward chemical, surges. Not a small release, a flood. The nucleus accumbens, a small region buried deep in the brain's basal forebrain, lights up like a switchboard in my old patent office. This is the same region that activates during cocaine use, during gambling, during any behavior that the brain classifies as potentially rewarding beyond the ordinary. This is where the comparison to cocaine begins. And let me be very clear about what scientists actually found, because this is not hyperbole. In 2002, researchers at Princeton University, led by neuroscientist Bart Hoebel, published studies demonstrating that rats consuming sugar showed patterns of dopamine release in the nucleus accumbens that were indistinguishable from the patterns produced by cocaine administration. Not similar, indistinguishable. The rats developed a dependency. When sugar was removed and then reintroduced, they showed classic signs of withdrawal and binge consumption. Hoebel's team documented neurochemical changes in the rats' brains that mirrored those seen in addiction models. The research has been replicated and expanded upon in subsequent years by multiple independent laboratories. Why does this happen? Let me take you back to 1905. Energy cannot be created or destroyed. It can only change form. That is the first law of thermodynamics, and it applies to the brain as surely as it applies to the stars. When sugar enters the brain, it does not simply provide energy. It provides a particular kind of energy that the brain interprets as extraordinarily valuable. The brain has an ancient system of reward prediction. It learned, over millions of years of evolution, to associate sweet tastes with high-calorie energy that would help survival. Fruit was rare. Honey was precious. The brain built a strong dopamine response to sweet because sweet meant 活下去. 活下去means survive. But here is the problem. The brain never evolved to handle refined sugar. Refined sugar did not exist during 99.9% of human evolution. The sweetest things our ancestors encountered were ripe fruit, maybe some honey, not crystalline white powder extracted from sugarcane or beets and added to every product on supermarket shelves. Not high fructose corn syrup poured into beverages that deliver more sugar in one can than our ancestors would have consumed in an entire month. The earliest evidence of refined sugar production dates to India around 500 BCE. For the vast majority of human existence on this planet, sugar was not a commodity. It was a rare and precious occurrence in nature. Our brains evolved in a world where sweet meant rare and therefore extraordinarily valuable. So when modern sugar hits the brain, the ancient reward system interprets it as the most significant caloric discovery since fire. The dopamine surge is disproportionate because the signal is disproportionate. The brain says, "This is extraordinarily important. You must seek more of this, now." This is where E equals mc squared becomes relevant, though metaphorically rather than literally. Energy and mass are equivalent. The more mass something has, the more energy it contains. Sugar has mass. Sugar contains chemical energy. But what matters here is not the caloric energy. What matters is the neurological energy, the cascading activation of neural circuits that produce craving, compulsion, and the subjective experience of pleasure. The brain is devoting enormous computational resources to the processing of this sugar signal. It is restructuring its priorities in real time. Within the first 6 minutes, the brain has already begun to change its expectations. It has updated its reward prediction. It now predicts that sugar will be available again. It adjusts dopamine release downward for ordinary foods and upward for sweet ones. This is called reward prediction error, and it is the same mechanism that drives all behavioral learning. When something is better than expected, dopamine spikes. When something is worse than expected, dopamine drops. Sugar consistently exceeds expectations because it is engineered, yes, engineered to do so. The food industry has spent decades optimizing the ratio of sugar to fat to salt in products specifically to trigger this maximum dopamine response. This is not accident, it is design. The products on supermarket shelves that sell the most are the ones that hit this exact neurological sweet spot. I used thought experiments to understand the universe. Let me ask you to imagine one now. Imagine you are a physicist observing a human being from the outside, with no access to the person's subjective experience, only measurable data. You watch the person eat a donut. Within 6 minutes, their brain is showing measurable changes in neurotransmitter activity. Specifically, a significant increase in dopamine in the synaptic cleft of the nucleus accumbens. Their insulin levels are rising, their blood glucose is elevated, their pupils are slightly dilated, their heart rate has increased by a small but measurable amount. You notice that their breathing pattern has changed, slightly faster, slightly shallower. Their galvanic skin response indicates elevated arousal. Is this a choice? The person picked up the donut voluntarily. They put it in their mouth voluntarily. But from a physicist's perspective, what you are observing is a series of chemical events that were, at their deepest level, determined by prior states. The person's previous experiences, their learned associations, their hormone levels, their gut microbiome, their sleep deprivation from the night before, all of these predetermined the response to that sugar. The feeling of choice is real, but the freedom to choose is circumscribed by the physical state of the system. This is the same paradox I confronted when I argued that time is not absolute. We experience time as flowing, but from the perspective of four-dimensional space-time, past and future are equally real. They already exist. We simply move through them. The same is true of our sense of free will. We experience choice as though it flows from us. But at the level of neurons and neurotransmitters and receptor densities and insulin gradients, the outcome is already determined by the physical state of the system. Sugar has changed that physical state within 6 minutes. The person eating the donut no longer has the same freedom they had 10 minutes earlier. This is deeply unsettling, and it should be. The cycle of sugar consumption is not a single event. It is a loop. After the initial dopamine surge, blood glucose rises sharply. The pancreas releases more insulin. Cells absorb glucose. Blood sugar peaks and then begins to fall. This is the glycemic peak and crash. Within 30 to 60 minutes of eating sugar, blood glucose can drop below where it started. You feel tired, you feel irritable. You feel a hollow sensation in your stomach. You want more sugar. This is not weakness of character. This is the predictable outcome of a biochemical feedback loop that evolved to help animals survive calorie scarcity, but now operates in an environment where calorie scarcity no longer exists. When our ancestors found a source of sweetness, they would eat as much as possible because they did not know when the next source would appear. That adaptive mechanism is now misfiring in an environment where sweetness is available on every shelf, in every vending machine, in every coffee shop. The brain, having experienced the high dopamine state, now predicts that another sugar hit will restore that state. The nucleus accumbens sends signals. The prefrontal cortex, which handles inhibition and decision-making, is less active in this scenario. You reach for another donut, or a coffee with sugar, or a soda. The cycle repeats. Each repetition strengthens the neural pathway. Each cycle makes the next sugar consumption more automatic. This is the same neuroplasticity that allows us to learn language, to develop skills, to form memories. It is a neutral mechanism, but in the context of refined sugar, it becomes a trap. The more you cycle, the more automatic the behavior becomes, until it operates below the threshold of conscious awareness entirely. Scientists at Princeton found that rats experiencing this cycle showed behavioral signs not just of tolerance, needing more sugar to get the same effect, but of genuine withdrawal when sugar was withheld. Anxiety, aggression, disruption of normal social behavior. The rats had become dependent. Not psychologically dependent in some vague sense, physically dependent. The brain had adapted to the presence of high sugar intake by altering its dopamine receptor expression. When sugar was removed, those receptors were suddenly understimulated. The result was measurable, observable distress. This phenomenon has a name in neuroscience: allostatic loading. The system adapts to the presence of the substance and then maintains its adapted state, requiring continued input to function normally. Now, what would a physicist observe watching a human being caught in this cycle? The same thing I observed watching light bend around the sun in 1919. The expected behavior did not match the observed reality. You expected the human to make a free choice. Instead, you observe a predictable response to chemical input. The universe is doing exactly what physics says it should do. The human is following the path of least resistance, as everything in nature does. Water flows downhill. Heat moves toward cold. The brain seeks the path of maximum dopamine release. This is not moral failure, it is physics. Every system in nature moves toward its lowest energy state. The brain, flooded with sugar and dopamine, is simply finding its lowest energy configuration. The problem is that the food industry has engineered environments where that lowest energy configuration leads to disease. But here is where I want to shift from diagnosis to prescription. Because I am a physicist, and physicists do not merely describe what is, we also ask what can be. And what can be, given this knowledge, is significant. The first thing to understand is that awareness changes the equation. When you know that sugar produces a measurable, predictable neurochemical response within 6 minutes, you are no longer operating in ignorance. Ignorance of the mechanism made the consumption feel like free choice. Knowledge of the mechanism does not restore complete freedom. I do not believe the universe works that way, but it shifts the battlefield. The conscious mind can now anticipate the cycle. It can plan for the crash. It can say, I know this will happen, and I am choosing to act differently before the cycle begins. This is not willpower. This is engineering. You are engineering a response to a known stimulus rather than being caught off guard by an unknown one. This is analogous to the principle of relativity. There is no absolute reference frame. But within any given frame, the laws of physics hold consistently. You cannot escape the physics of sugar. But you can choose your reference frame. You can view yourself as the observer rather than the observed. You can step back and notice the cycle rather than being swept through it. The moment of observation is the moment of leverage. The second thing is that the brain's plasticity works in both directions. If sugar consumption strengthens neural pathways for craving, then reducing sugar consumption weakens them. This is not instantaneous. It requires weeks, sometimes months, but it happens. The dopamine receptor density in the nucleus accumbens can renormalize. The glycemic response can stabilize. The conditioned expectation of sugar can diminish. The brain is always learning. It learns the pattern of sugar. It can also unlearn it. This is the same principle that allows a musician to master an instrument or a language learner to become fluent. Consistency over time produces structural change in the brain. The same mechanism that built the addiction can dismantle it. The third thing is structural. The environment shapes behavior more powerfully than willpower. I published the theory of general relativity in 1915. One of its key insights is that matter tells space-time how to curve, and space-time tells matter how to move. The environment shapes behavior more powerfully than willpower. If sugar is visible, accessible, socially normalized in your environment, you will consume it. This is not speculation. This is the demonstrated pattern across every society where processed sugar has been introduced at scale. Obesity rates, type 2 diabetes rates, metabolic syndrome rates, all track with sugar availability, not with individual moral character. In a world where sugary foods are cheap, accessible, and socially reinforced, predicting low sugar consumption requires going against the grain of the environment. That is a structural problem, not a moral one. So the practical prescription is this: remove sugar from your immediate environment, not because you lack willpower, but because you are making a structural choice that affects the physics of your situation. Do not keep sugary snacks in your home. Do not drink soda. Read labels. Understand that high fructose corn syrup is sugar under a different name. Choose whole foods. The brain's expectation of sugar weakens when sugar is not available to meet that expectation. This is not deprivation as a moral act. It is engineering your environment so that the path of least resistance leads toward health rather than disease. When the easiest choice is the healthy choice, health becomes the default rather than the achievement. Let me also address something that puzzles many people who study this issue. Why does sugar affect some people severely and others less so? The answer lies in individual variation in dopamine receptor density, in insulin sensitivity, in gut microbiome composition, in sleep patterns, in stress levels, in genetic predispositions. But here is what is consistent. In everyone who consumes refined sugar, the 6-minute dopamine response occurs. The magnitude varies. The downstream effects vary. But the mechanism is universal. This is not about weakness, it is about chemistry. Some people's chemistry makes them more resistant to sugar's effects. Others are more vulnerable. But the vulnerability is not a character flaw, it is a biological fact. I want to close with something personal. When I was a young man, I failed the entrance exam at ETH Zurich. I was 17 years old, and I was not yet the person I would become. For years, people told me I was not smart enough, not disciplined enough, not capable of doing the work. They were wrong, but for a long time I believed them. What changed my trajectory was not believing in my talent. It was understanding what I was trying to do and building the conditions that made it possible. I found the patent office in Bern. I had time to think. I surrounded myself with problems that mattered. I created an environment in which the work could happen. No one gave me permission. No one certified me. I simply built the conditions and let the physics take over. This is what understanding sugar does for you. It does not make you immune to addiction. It does not give you superhuman willpower. What it gives you is the ability to build the conditions in which a different outcome becomes possible. You stop believing that your failures are moral failures and start engineering the physics of your situation differently. You stop blaming yourself and start redesigning the system. Imagine the physicist watching you from the outside. They see you make a choice. But now, with this knowledge, that choice is more fully your own. Not because you have escaped the physics, you have not, you never will, but because you have seen the machine and you have decided to step outside its immediate pull. That is not nothing, that is everything. Subscribe. Leave a comment. What is one change you could make to the physics of your environment right now to reduce sugar consumption? I read every response. The distinction between feeling in control and actually being in control is, like the distinction between past, present, and future, only a stubbornly persistent illusion. But some illusions are more worth dismantling than others. This one matters. Your health, your cognitive clarity, your emotional stability, your long-term metabolic function, these are not trivial things. They are the platform on which everything else in your life is built. When the platform is unstable, everything built on it shakes. A man once asked me what my opinion was about God. I told him that God does not play dice. I meant it as a statement about the universe. The universe, at its deepest level, is comprehensible. It follows rules. The chaos we see is the result of complexity, not randomness. Sugar and the brain is the same. It feels chaotic. It feels like you are losing control. But there is a structure there. There is a mechanism, and once you understand the mechanism, you can work with it instead of against it. That is the gift of science, not control, but comprehension. And comprehension gives you leverage. That is what I have tried to show you today. Not a moral lecture, not a dietary prescription, a physicist's analysis of what happens inside your skull when you eat something sweet. 6 minutes. That is all it takes. The dopamine floods in. The nucleus accumbens lights up. The reward prediction updates. The cycle begins. Now you know exactly what is happening in those 6 minutes. You know why it feels like compulsion. You know why it feels like addiction. You know why willpower alone is not enough. And you know that the solution is not moral effort, but structural change. Build the environment. Change the physics. Let the path of least resistance lead somewhere better. The rest is up to you.